use the symbols of less than, greater than, less than or equal to, or greater than or equal to. These are the inequality symbols. Now, for example, what if I have x less than or equal to 2? This means on the real line, in the middle I have 0. On the far left I have negative infinity. On the far right I have positive infinity. 2 is to the right of 0. This is a full point. Why is it a full point? Because of the equal symbol. And the interval notation uses a bracket. X to the left of 2. So this is 2. Everything to the left of 2. So this will be the interval notation, representing negative infinity 2. Infinities are not numbers. So therefore, we always use parentheses for infinities. Now, if the inequality symbol has the equal symbol, then I will have to use a bracket. If it does not, like for example, x greater than negative 3, how will I represent this in interval notation? So 0 is in the middle, far left negative infinity, far right positive infinity, negative 3 somewhere here, but with an open point. And an open point means actually parentheses. And it says to the right of negative 3. How will I write the interval notation? Exactly what I see. Negative 3 to infinity. Again, x less than or equal to 2, from negative infinity to 2, including 2. When we say including 2, we mean a full point, and we mean bracket. Here, x greater than negative 3 means not including negative 3, but everything else, from negative 2.99999. So from that point to the right. Now, I can also have something like in between. What does that mean, in between? Here it is. Let's say x is greater than or equal to negative 3, but less than 4. This is an in-between situation. How will I graph it? Very simple. 0 in the middle, negative infinity far left, positive infinity far right. Negative 3, I'm not going to count, it doesn't matter. So negative 3 with a full point, but 4 with an open point. I will use a bracket at negative 3. I will use a parenthesis at 4, and everything else in between. So the interval notation uses exactly what you see here. Negative 3, comma 4. Now, what I normally write is, I always write x in the interval. Why? Although this is not confusing, it's very clear, negative infinity to 2. It cannot be an ordered pair. Same thing here. This is very clear. Negative 3 to infinity cannot be an ordered pair. Here, it's an overkill if you want, because negative 3 with a bracket, 4 with a parenthesis, is very clear. But what if I have this? When I write the interval notation, I write this. But you can say, wait a minute, is this a point? Is this an interval? What are you talking about? But if I put in front of it x in, it's very clear now that this is an interval, it's not an ordered pair. In other words, x is not 2 and y is not 4. Because a long time ago, when we plotted 2, 4, we came up with 1, 2, 1, 2, 3, 4, and this was this point. And it's a confusing notation. Is it a point? What are you talking about? But no, if I put this little thing in front, x is a number in the interval 2 to 4, but not 2 and not 4, this becomes very clear. For that reason, I always use, in front of the interval notation, I always put x in. So it's super clear that this is not an ordered pair. Although something like this.
So 2 would be your input and 4 would be your output.
That's what I'm trying to say.
Yeah, gotcha.
That this is not that.
No, not that.
No, this, once I put x in, it means that x is a number anywhere between 2 and 4, but not 2 and not 4. Has nothing to do with this.
Gotcha. Okay.
Because I put in front of it x in.
Gotcha.
Any questions? Okay. Okay, so back to 7.2. Let's start. Good. So how will you graph x greater than 6? A, B, C, D.
D.
Yes, because we have to use a parenthesis. It's greater than 6, parentheses, a parenthesis at 6, and direction to the right towards infinity. Good. X less than or equal to negative 8. A, B, C, D.
B.
Yes, because you have to use a bracket. The bracket has to be at negative 8, and it's everything to the left of negative 8. Very good. Graph the inequality, x greater than or equal to negative 2. A, B, C, D. Yes, a bracket at negative 2 and direction to the right. Use interval notation to express the inequality shown in the graph. Can anyone tell us what is the inequality in the graph? You mean from negative 3 to infinity? Is that what they mean?
I think the solution says 0.
That 0 is the empty set. But what? What? That's a good one. That's a good one. Is this just because they are not showing anything? Oh my
This
goodness.
is a trick question.
Well, the coordinator of this course is looking at a different book, so I'm glad that she's doing that. Okay, that's a good one. Okay, I see. Use interval notation to express the inequality shown in the graph. So let's talk about this. To show the whole thing, the entire real line, we have to write this. This is how we show the entire real line. An interval notation from negative infinity to infinity. Now, so the solution set, and it should give me an infinity somewhere. Okay, here it is. So we put parentheses, we go back in, negative infinity, and then we put a comma, and we put infinity. That's how we write the whole thing. Okay? It goes from negative infinity to infinity. 3 ways to describe an interval are set notation, a graph, and interval notation. Write the set notation. Okay. So this is called set builder notation, and here all you have to do is just write that x greater than or equal to negative 9. So let me explain this. What does this notation mean? So I see that the interval is x greater than or equal to negative 9. So I can present this in an interval notation, which is negative 9 to infinity. Or I can say is the set of all x values having the property. This vertical bar means such as, or having the property. What is the property? X must be greater than or equal to -9. So this is the so-called set builder notation. So we either say x is greater than or equal to -9, or we say the interval notation is -9 to infinity, or we say that the solution set consists of all values of x having the property, such as having the property that this x must be greater than or equal to -9. 3 different ways of writing the same thing. So the first one, x having the property that x is greater or equal to -9. Here's the graph. We type the inequality, and now it's going to probably ask us to type in the interval notation or not. Yes, so the interval notation has to have the bracket, has to have -9, has to have comma, has to have infinity, and has to have a parenthesis. So number 1 is the graph. Number 2 is the set builder notation, and number 3 is the interval notation. Good. Express the given interval as an inequality. So we're going backwards. Now they are giving us the interval, and they want us to come up with the inequality. So if I have the interval that x is in -infinity to 5, what will you say, what inequality fits here?
X is less than or equal to 5?
Not less than or equal to, but just less than, because we have parentheses.
Oh, yes.
Perfect. Good. Excellent. Good. Write inequality that results from dividing both sides. Very good. So we have an inequality, and this is a very good exercise. 16 less than 20, and they want us to divide by -4. So we're going to solve inequalities. They're very simple. They're based on solving linear equations. Very simple. But so if I have, for example, 3 less than 4, and I decide to multiply both sides by 2, 3 times 2 is 6, 4 times 2 is 8, the inequality symbol does not change. So whenever I multiply or divide by positive numbers, both sides of an inequality, nothing changes other than I multiply or divide. So 3 times 2 is 6, 4 times 2 is 8. So then the sign still is true. It's correct. However, whenever we divide or multiply both sides of an inequality by a negative number, the symbol, the inequality symbol, has to flip. Mandatory. So when I divide 16 by -4, I get -4. When I divide 20 by -4, I get -5. Notice that this is not possible anymore. -5 is not greater than -4. Therefore, we have to switch the inequality symbol. It was less than, now it's greater than. Because multiplying and dividing both sides of an inequality by a negative number changes the direction of the inequality. It does not when we multiply or divide both sides by a positive number. That is carved in stone. It's the same. Nothing changes. But if we multiply or divide both sides of an inequality by a negative number, we have to flip the inequality symbol, because this was true. 16 is indeed less than 20. But -4 is not less than -5. -4 is greater than -5, because -4 is to the right of -5. So please remember, this happens only when we multiply or divide both sides of an inequality by a negative number. Okay, so now we want to finally solve inequalities. 4x plus 6 less than 6. The only difference here is that the answer will be an interval notation versus the solving equations, linear equations, in which the answer was a finite solution. Of course, I have to move 6 to the other side, and I have 4x less than 0. Of course, I'm going to divide both sides by 4, as we did before with linear equations, and I get x less than 0. And now I have to write this in interval notation. So x is in where? And since we read from left to right, actually math is done in other languages that write from right to left, also from left to right. It doesn't matter. Less than 0, meaning we have to start at negative infinity and stop at 0, but actually before 0, because there is no equal symbol. So the interval notation is, we start from far left, negative infinity, to 0.
Why'd you move the 6 to the other side?
That's how we solve linear equations and linear inequalities, the same thing. We have to isolate x. This 6 cannot be next to 4x. We cannot combine them. So it has to be moved to the other side exactly as we solve linear equations. Is that okay? Perfect.
So basically we're moving from equals to lesser or greater.
Exactly.
Okay.
That's the only difference. Okay, so let's solve these 4 inequalities. Let me copy them first. So we have 4x greater than or equal to 8. We have 4x greater than or equal to negative 8. We have negative 4x greater than or equal to 8. And negative 4x greater than or equal to negative 8. Perfect. So let's work on this. The first one, what will you do to solve for x?
Divide by 4.
Yes. So then this stays as is, meaning I do not change the inequality symbol or flip it, because I divided both sides by a positive number. In interval notation, I have to write the bracket 2 to infinity. What happens in the second one?
Divide by 4.
Yes. So then I have x greater than or equal to negative 2. I divide it by a positive number. Nothing changes. The bracket negative 2 to infinity. So this time it starts at negative 2 and goes to infinity. Now I have to be very careful. What do I need to do next in the next problem?
Divide by negative 4?
Correct. So yes, I have to flip the sign because I divided both sides by a negative number. So negative 4 divided by negative 4 is 1. 8 divided by negative 4 is negative 2. But I divided both sides of an inequality by a negative number. We have to flip the symbol. And now the interval notation is from negative infinity to negative 2 with a bracket. Because now when we read the inequality, it reads x less than or equal to negative 2. So we have to go to the left. Or we have to start far left. Good. Last one here.
Divide by negative 4?
Very good. So then from here I have x and 2. But what do I need to do?
Flip it?
Yes, I have to. From whatever I had to the opposite. And now the interval is negative 2 to 2, negative infinity to 2. Is this okay?
Like learning a new language.
Yep, yep, I agree. When solving an inequality, when does it become necessary to reverse the inequality symbol?
When dividing
Yes.
by,
When each side is divided by the same negative number, when each side is multiplied by the same negative number as well. When each side is multiplied by the same negative number, when each side is divided by the same negative number. When the same number is subtracted, no. When the same number is added, no. When each side is multiplied by the same positive, no. I just want us to solve. Okay, ready. So 1/2 p minus 5 greater than p plus 8. We're asked to solve the inequality and express the set builder notation with a bar, with a vertical bar, graph the solution, la la la. Perfect. Okay. Knowing me, and hopefully you learned something from me, you know what I'm going to do first.
Times it all by 2.